Hey everyone, welcome. Today we're going to tackle a topic that sounds like it's straight out of a sci-fi movie, quantum computing. But don't worry, I promise we're going to break this down using some really simple, everyday ideas. By the time we're done here, you'll get exactly why this is such a huge deal. So, let's just dive right in.
Okay, to kick things off, just think about this one simple question. Picture a light switch. It's either on or it's off. That's it. Pretty straightforward, right? But what if it could be both, on and off, at the exact same moment? That one kind of weird idea, that's the key. That's what unlocks this whole thing.
So before we jump into all that quantum weirdness, let's take a step back and just ground ourselves in the world we all know. The world of our laptops, our phones, all the devices we use every single day. Yep, that's right, every single piece of tech you use. I'm talking from the biggest supercomputers on the planet all the way down to the phone that's probably in your pocket right now. It all works on this super simple principle. It's either off or it's on. It's amazing, really, how we've built this incredibly powerful system on such a simple idea.
And there's a name for that little light switch. We call it a bit. A bit is the most basic, the absolute smallest piece of information your computer can understand. It's a 0 or a 1. It's off or on. Yes or no. There's no gray area, no in between. Think about it. Every photo you've ever taken, every text you've sent, it's all just a gigantic collection of these tiny, simple switches.
Okay, so we've got the bit down, right? Simple enough. Now let's leave that familiar world behind for a second and introduce the real star of the show today. This is the ingredient that just changes the game completely. So on one side, you have our good old bit. It's a 0 or a 1. Simple. But then you look at the other side and you see the qubit, the quantum bit. And this thing has a secret power. It can be a 0, it can be a 1, or it can be both at the exact same time. And this, right here, is where the rules of the game totally change. Now, this both-at-one state has a kind of fancy name. It's called superposition. I know it sounds super complicated, but it's not. It really is just that simple idea. It's the special ability to be in multiple states all at once, and it's our first glimpse into the weird but incredibly powerful rules of the quantum world.
To make this even clearer, let's try an analogy. Let's forget about computers for a minute. Just think about a coin. It's actually the perfect way to really see the difference here.
Okay, so a normal bit, that's like a coin that's already landed on the table. It's either heads or it's tails, a 1 or a 0. Definitive. But a qubit? A qubit is like that same coin, but while it's still spinning in the air, right? In that moment, before it actually lands, it's not really heads or tails. It's kind of a mix, a blend of both possibilities all at the same time.
So we've got this spinning coin, this qubit in superposition. Okay, cool, but why does that matter? Why is that so revolutionary? What's the superpower that this gives a quantum computer?
And there it is. That's the secret sauce right there. Because these qubits can hold multiple values at the same time, a quantum computer can check out a huge number of possibilities all at once. It doesn't have to go through things one by one. In a way, it kind of gets to cheat.
Here's a way to think about it. Imagine a normal computer has to find a toy hidden in one of, say, 100 boxes. What does it do? It opens box number 1, takes a look. Then it opens box number 2, takes a look, and so on. It's fast for sure, but it's still doing things one at a time.
But a quantum computer, well, it can use that special both-at-once power to basically peek inside a whole bunch of those boxes at the same time. It gets to look at the whole problem all at once to find the answer.
And this maze example really nails the difference. A normal computer trying to solve a maze, it'll try one path. Oh, dead end. Okay, backs up, tries another one, and so on. But a quantum computer, it gets to explore all the paths at the exact same time. It can basically see the path to the exit almost instantly.
Okay, so this sounds like an absolutely unbeatable superpower, right? And for certain kinds of problems, it really is. But, and this is a really big but, it's not perfect. It's not the solution for everything. This incredible power comes with some major, major challenges. So here's the catch. That spinning coin state, that superposition, it is unbelievably fragile. I mean, the tiniest little vibration, a slight change in temperature, even just trying to look at it can cause that coin to land, and poof, the calculation is gone. These weird quantum rules are what make it so powerful, but they also make the whole system incredibly fragile, crazy expensive, and, for now at least, very experimental. And that's exactly why you're not going to see a quantum computer replacing your laptop anytime soon. They're not built for that.
Instead, they're being designed to solve humanity's biggest, gnarliest problems. I'm talking about the kind of stuff that's just impossible for even our fastest supercomputers today. Things like discovering new medicines, designing brand new materials, or on the flip side, breaking the complex codes that keep all our data safe. That's where the real potential is.
And just to be super clear, they are actually terrible at the things our normal computers are great at. You're not going to be browsing the internet, playing a video game, or watching YouTube on a quantum computer. It just doesn't make sense. Think of them as highly specialized tools for very specific world-changing jobs.
So let's do a quick recap here. A normal computer thinks in zeros or ones. A quantum computer uses zeros, ones, and both at the same time. A normal computer solves problems one path at a time. A quantum computer explores tons of paths at once. And, really important, normal computers are stable, easy to control. Quantum computers, super powerful, but man, they are really hard to control. You know, if you remember just one thing from all of this, let it be this idea right here. It just perfectly sums it all up. It's not about being faster, like a sports car is faster than a bike. No, it's about playing by a completely different and, let's be honest, much weirder set of rules. It's a fundamentally new way to solve problems. And it makes you wonder, right? What other problems, things we think are impossible today, could we solve once we really master these weird little rules? That is the multi-billion-dollar question.